Hello and welcome to Virtual Investor Conferences. On behalf of OTC Markets, we're very pleased you have joined us for our AI and Technology Conference. Our next presentation is from CCOM Satellite Systems. Please note you may submit questions for the presenter in the box to the left of the slides. You can also view a company's availability for a one-on-one meeting by clicking Book a Meeting in the top toolbar. At this point, I'm very pleased to welcome Dr. Leslie Klein, President, Chief Executive Officer, and founder of CCOM Satellite Systems, which trades on the OTCQB venture market under the symbol CYSNF and on the TSXV under the symbol CMI. Welcome, Leslie.
Thank you, Greg. Thank you for inviting me to the presentation, and thank you to all of your attendees who are here this morning. I'm happy to present the company, and I will just click to the next slide, which is the typical CCOM disclaimer for the presentation. I will not read it, but at least it's up there for everybody to see. The company I started 28 years ago was started for the purpose of delivering high-speed broadband connectivity into vehicles and deliver this service in remote areas. So the products that we manufacture are antenna systems that connect to a satellite without the need of knowing anything about satellites, because you can do it with one press of a button. The antenna locates the satellite wherever you are around the world, and within minutes you are connected. When you finish your transmission or your internet connection or whatever you are using the internet for, it will with another push of a button, the antenna will fold and you will be able to drive away. So the technology that we developed 28 years ago is used all over the world, and the company is one of the largest manufacturer of these type of antennas, which are called communication on the pause. It is on the pause because you have to stop to use it, and when you're driving, you cannot use it. That type of communication is called communication on the move, and CCOM is also developing that technology with the new low Earth orbit satellites that are being launched at a rapid clip. We are also developing an electronic antenna that will operate on these satellites, and the chipset that is used to make these antennas possible to form the beam and deliver mobility into vehicles, planes, boats, whatever. The company has 26 people. We are relatively small. Greg mentioned the symbols. They are on the screen. And the company, over the 28 years, it has been public about 25 years. We only raised about $5 million at the time when we went public in the early 2000s. And we have never gone back. We have never raised any more money. The company has been profitable throughout most of the 28 years of its operation, and it actually operates on its own strength. It has about $23 million of working capital, of which about $16 million is cash. It has paid out over the last 10 years about $25 million in dividends. And it's, as I mentioned, developing this revolutionary technology that should launch next year and be available to be sold around the world. The company has sold over 11,000 antennas in 106 countries. We sell them over through a reseller network. So we don't have sales offices in those countries, but we have about 600 distributors and integrators who buy the product from us, and then they sell it to their customers. The company has developed a multiple number of different antennas models, and they operate with many, many different satellite modems and in different frequencies. As I mentioned before, also the company has no debt, and it actually is not looking for any funding. It operates from its own resources and develops the technology using its own funding. The vertical markets that the company is addressing are essentially pretty much all kind of markets, all kind of applications around the world wherever internet is used, which is pretty much everywhere, including governments, militaries, oil and gas companies, cellular telephone companies, banks, hospitals, schools, mining, etc. I'll show you some applications later on as to how they're used, where they're used. The antennas, as I mentioned, about 11,000 of them are all over the world. And this map just gives you an idea of where they are. And these are not all 11,000 of them, but just some of them that the distribution of them, you can see it interestingly, very, very dense in North America and also in most of Europe, where you would think that there's plenty of connectivity available. But it looks like, based on the antennas that we are selling all over the world, there is demand for satellite communication and demand for the type of products that we are manufacturing. Just for example, you can see New Zealand down in the right-hand corner, where most of the fire departments have our antennas for disaster management. So it's pretty much packed. Australia is mainly for oil and gas, and also Northern Europe, oil and gas. And then we have in the Middle East, quite a bit of it is also oil and gas type of application. In Indonesia, we have military installations. And also in Europe, quite a number of NATO forces have our antennas used for military type of applications. The products that we manufacture can be broken down into driveaways, which sit on vehicles. And essentially, they are from about 74 centimeter size all the way up to 1.8 meter. And the sizes of the antennas reflect basically the bandwidth requirements. The larger the antenna, the more bandwidth you can deliver with them. And also they could be used in further away from where the satellite footprint is, so that you can utilize the full capacity of the satellite with a larger antenna that is on the edges of the satellite coverage. The flyaways are in transportable cases. They are designed to be toolless, so you can actually put them together and take them apart without any tools, put them into the transportable cases, and then transport them either on the back of a truck or in a helicopter. But they can be very rapidly assembled within minutes and deployed. So it makes it possible to have satellite connectivity pretty much anywhere in the world at any time if you have this type of a solution. We also have fixed mobile antennas, which are basically typical satellite antennas, but have the ability to move automatically in azimuth elevation and polarization. So they are used in very remote areas where if something happens like an earthquake or a very large wind that would displace the pointing of the antenna itself, you can press a button or you can remotely connect to the antenna and have it repoint itself. So they're used in very specific applications in very remote areas where flying a person in could take thousands and thousands of dollars, and also it could take a couple of days to get there and get back just to repoint the antenna that has misaligned itself for whatever reason. The controller of the system is a picture of it here. We have different controllers. They are the same technology, but they're packaged differently. Some for the flyaway antennas and some for vehicle mount antennas, and also ones for the MEMPAC, which is a unique product that allows you to actually carry the antenna on your back and can be deployed within minutes, and it will find the satellite within seconds. I'll have a slide on that for you in a minute. This slide just shows you how the antennas are stowed and deployed, and also they have different feed assemblies for different services. So if you are a Eutelsat or a Hughes or a Viasat customer, you would have your own specific feed assembly to be used with the antenna that is recommended and approved by the service provider. So we make these antennas unique in a way that they can be easily swapped out and can be supported by Hughes, Viasat, Eutelsat, many other service providers. So this is a 74 centimeter antenna. This would be a 98 centimeter antenna. You can again see the number of feeds that it has available for different services. And then this one is a 1.2 meter satellite antenna that is used for broadcasting. It has some specific features that broadcasters need, and you can see It has a cowling on it to make it aerodynamic for vehicle mounting, and you can see it's stowed and deployed. The flyaway antennas, as I mentioned, come with a tripod, and they can be very rapidly disassembled, put into the cases, and they're essentially using the same type of controller technology that I showed before, but they are designed for transportability, not designed to be sitting on top of a vehicle. The MEMPAC is a carbon fiber antenna that is very light. It's about 20-some pounds and fits into one backpack. You can actually take it apart within minutes, put together within minutes, again, without any tools, and with a press of a button that is part of the antenna itself. The controller is part of the antenna itself. It will find the satellite within 30 seconds or so. And you can take it with you pretty much anywhere and have connectivity over a satellite that is covering the region where you are planning to operate it. We have sold quite a number of them, multiple hundreds, to cellular backhaul for SoftBank in Japan, and also for a number of militaries in Asia who are using it for military type of applications, because they can be easily transported by one person, and they're light and they're very rapidly deployable. So it just shows you some additional pictures of different sizes. We have 60 centimeter, 80 centimeter, 1 meter, and 1.3 meter of these type of antennas available. We have a very large inventory of about $6 million worth of product, so we can ship these very rapidly to customers who need them during disaster management or some emergencies, or for military applications that are they're requiring very fast delivery. So rather than wait 4 months to have these manufactured, we can ship large quantities of them rapidly from our warehouse. This is a military version of the same MEMPAC. We have sold quite a number of them to militaries around the world, most of them in Asia, and quite some of them to the US military, as well as to some NATO forces in Europe, and a few of them in Canada as well. The typical application of this product you can see here would be also in broadcasting. You can see this in the Rocky Mountains of Canada. The antenna is being used to shoot a commercial and actually transmit the video directly into a studio for immediate editing. So you can bring it with you, you can connect it to a power source up in top of a mountain, and when you're finished, you can take it with you back and transmit it, all the data, all the information, and at the same time you can have internet connection up on top of the mountain if that's what you want to have while you are shooting a commercial. These are similar applications used in Japan. You can see a cellular backhaul capability here. When Japan lost, during the Fukushima disaster, Japan's SoftBank, they lost over 200 or 300 cell towers. These antennas were pretty much rapidly replacing them and making it possible to deliver connectivity within days rather than months that it would take to replace a cell tower. So you can see a MEMPAC here, and you can see also a larger flyaway antenna being deployed in Japan, and a person carrying the antenna during a hurricane or flood disaster, post-disaster. Other applications would be oil and gas. They're all over the world, from Australia to Libya and China and many other places where oil and gas exploration is taking place. They're perfectly usable products because you don't need to know anything about the satellite. The driver of these vehicles, the exploration vehicles, can operate the antenna by pressing a single button to get connected, and then when he's finished with the transmission of the data, he pushes another button and moves on to the next oil and gas exploration location. News gathering for television stations of all type of applications, from Mongolia to Angola in Africa. Pakistan, we have multiple television stations in many of those countries that actually deliver broadband connectivity to the studios. One television station in Pakistan has over 50 of our antennas so the reporters can drive around and deliver instant news from various locations in Pakistan, for example. Emergency response, there's a lot of fire departments in London, for example, also in Japan. We have in Osaka, we have about 25 antennas with one fire department. And we also have them in Japan and many other places where, including New Zealand, as I mentioned, where disaster management and also fires are very important to have connectivity. These fire trucks would need connectivity in areas where there's no other way to get communication established. Telehealth is another vertical market. We have mobile breast screening units. We have mobile ambulances. We have a Walgreen vaccination clinic that is using the antennas for rapid connectivity where in remote locations. And we also have some mobile surgery units around the world. One is in New Zealand. We have some in Loma Linda University in the US. The other vertical market, of course, is military. We have a number of military systems with the US military, with the Polish military. We also have Vietnam as a customer, Australia, New Zealand, and many other militaries who use the system for communication purposes. Telecom, cellular backhaul is very big with telecom and instant connectivity where there is a requirement to offload some of the local cell service. For example, if you have a rock concert where there's 100,000 people, you may want to have one of these antennas that would be used as a backhaul to free up the bandwidth from the local situation wherever the concert is, so that it's not affecting the population that is in the area, and it's actually a dedicated bandwidth, a solution for the cell company to provide to 100,000 or so customers suddenly who are in an environment where they would be taxing the services of the cellular coverage that is where the concert is taking place. Mobile offices, we have over 150 antennas in South Africa with the government of South Africa for delivering pension checks, for example, where these vehicles go out and actually print pension checks in very remote areas of South Africa. In Argentina, on the right side of the presentation, you can see about 35 antennas that were sold to the local telephone company there that is providing the government with passport printing capabilities. And inside all these vehicles are passport printers, so that they actually travel around Argentina and deliver services, government services, including passport printing for the government by connecting to the government offices and producing passports on the spot. Mobile banking is also very big. We have the systems all over the world, from Spain to Africa to Hawaii. In Germany, for example, we have a system used on a very large vehicle that you can see here that is used as a test vehicle to determine if a fixed ATM machine is feasible in a location where this vehicle will be parked for about a week. If there is enough traffic in there, then they would put in a permanent ATM machine, but the vehicle just moves from one location to another. It's a test vehicle to determine the requirements for permanent ATM machine locations. In South Africa, we have vehicles also that say there's no cash in them. They are used with cell phones. So you can actually walk into the vehicle as an ATM machine and fill your phone with cash, so to speak, and use the phone to pay your bills or whatever, your purchases. And you don't have to actually go to locate a bank or a specific ATM machine. These vehicles travel all over South Africa and provide these type of services. Sorry. The next big thing in satellite communication is the golden age of the satellite business that is innovating very aggressively. It's becoming a totally different business than it used to be 5 years ago because of SpaceX launching of over 10,000 low Earth orbit satellites. And also there's other players now. There is Amazon, there is OneWeb, Telesat is launching about 200 satellites. And Bill Gates is also involved in a project where he's building some antennas for the existing constellations. CICOM about 7 years ago started developing the technology that would work over these type of satellites. These are satellites that are in constant motion, so they're no longer geostationary or geo. They are either LEO or MEO, which is low Earth orbit and medium Earth orbit. And these would be satellites that constantly move. They are at about anywhere from 400 to 600 to 1,000 kilometers height, as compared to 36,000 kilometers of the geostationary satellites. And the satellite business is now about a $330 billion market, with the antennas representing today about a $4 billion opportunity. So CICOM started developing an antenna that would make it possible to track these satellites electronically, because the parabolic antennas that we manufacture today cannot be used on a vehicle and or a plane or a boat to work with these satellites, because they are moving, and so is the vehicle or the plane or a boat. So you need an electronic antenna that can track them. So here you can see, for example, a constellation of the Telesat constellation that's going up in about 2 years, and our antennas are being tested presently on this constellation. You can see that this covers also the northern hemisphere of the world, of the Earth, while the SpaceX satellite, the constellation that's beside it, is skipping that part. So, and it's much more dense, which means that they have about 10,000 satellites here, and Telesat will have about 200. But it's a different service, different application, and it's more commercial. This is more consumer. So our antennas will work on any type of constellation, GEO, LEO, or MEO, as long as it's not the SpaceX constellation. It's proprietary. You have to buy the service, the antenna, the satellite, everything is proprietary to SpaceX, while the Telesat constellation will be open-ended, which means that any type of a satellite antenna that has the capability electronically track it and would be usable on that service, and it's not designed to be a closed type of a network. So our electronic antenna is basically, you can see it's a 4x4 array of antennas, the size of a Canadian quarter, and you take those 4x4 elements and you build from it a 1,000 element antenna that becomes essentially capable of electronically track those thousands of potential low Earth orbit or medium Earth orbit satellites, but it will also work with standard geostationary satellites. The proof of concept we have completed in about 5 years ago, and we've done tests about 4 years ago. So we know that this technology that we developed is working. We are in the final stages of manufacturing this technology. The antenna is conformal. It can do a 360-degree scan, and hopefully it will be our next hot product going into the next generation of satellite antennas. Just to give you an idea, this is how it's put together, and this is the final end product of the antenna itself. I'm going to speed up here because we're running out of time. You have a mechanical antenna here compared to an electronic antenna. So you can see there's huge differences in size, weight, and many other features of it. The fact also is that it's thin, light, and can sit on top of a vehicle and can scan these electronically, scan the satellites that are constantly moving. So this is just the same picture. Here's just a slide of the panel market that is going to grow at the rate of 14.1% CAGR, and most of them are going to be electronic in the next 10 years. and most of them will be in the same frequency band that we are manufacturing them. So it is definitely going to be a huge market, and you can see here about a $4 billion potential market, most of it government, military, and also broadband access is going to be very high, and mobility, of course, is the key to all of this. This is what the antenna looks like on top of a vehicle. This is what it would look like on top of a train. It's a simulation. And on an aircraft, you can have multiple antennas on the aircraft, and I'm sure you've seen these type of antennas on the aircraft already, and some of them are still mechanical antennas that have gimbals under it, but more and more of them are becoming electronically steered. CCOM is also developing the technology for these antennas, which are, as I mentioned, electronic antennas. We are developing the integrated circuit that is these little antennas behind these little antennas is an integrated circuit that makes beam forming, the forming of the beam electronically possible. And in order for us to control the manufacturing process of the antennas and also deliver the antenna itself complete, we have designed and developed this beamformer integrated circuit that forms the heart of the electronic antenna. We are starting to manufacture these early next year also. So we'll have a new market for these beamformers that are also going to be used in many other IoT type applications, and will generate new revenues for the company. So the beamformer is probably, you can see the chip is the size of a quarter, and one is used for transmission and one is used for reception. It's a multi-channel integrated circuit that is being manufactured for us in the US by a foundry, a large foundry. And this is what it looks like, essentially as a test board, which we are starting to send to customers this year for them to test and verify that it does the work for them. And we'll be manufacturing these also by early next year. As I mentioned, they will be generating us a new revenue stream, which we are not presently addressing. Thank you very much for your attention. And if you want to reach me, you can see my email address and the company's web address on this slide, and I'll leave it there for you. If you have any questions, please feel free to ask. There is a question here from Maria Colgan. I'll read it for you. How should investors think about the timeline and criteria for success of your next phase of anticipated changes to the strategic partnership, dealer relationship, or supply chains that could that could materially affect, I guess it's dropped. Well, as I mentioned before, we are going to be starting to develop, manufacture the antennas next year. And we expect that this new antenna product will be providing revenues, incremental revenues to our existing legacy products. And the chips also that we will be making are going to be utilized not only in our own antennas, but will be also utilized in other applications. So there's a lot of interest in the integrated circuits as well to buy from other companies that are going to be building satellite-based beamformers for IoT applications and many other satellite-based applications using services of GEOs, LEOs, and MEOs that are going to go up there in a very large number. It is expected that there'll be over 100,000 satellites within a matter of 4 to 5 years up there, and there'll be a lot of opportunities to sell both electronic antennas and integrated circuits to this customer base. There's a question from Larry Casey. What are the most significant risks or uncertainties facing the company over the next year, and how is management mitigating them? The risks are, of course, always there. Supply chain is a risk. Component availability is a risk. New disruptive technology is a risk. But we believe that we have been in business 28 years, and we have faced similar risk and similar problems over the 28 years, and we made money. We paid out $25 million in dividends. We are operating profitably we have our own cash. We have no debt. So we believe that, and we are a very small company. We don't manufacture anything. Everything is outsourced. And therefore, we believe that we can mitigate any of the risks that we will be facing. And those are going to be definitely some that we will have to take into consideration. But we are managing under the circumstances to mitigate all of those and figuring out how to exist and coexist and get to the marketplace that is not that easy to navigate. I think I still have some time. There's a question here from Matthew Osley. Can you elaborate on the status and commercializing path for electronically steerable phased array antenna and beamformer? So the commercialization is through our resellers. We intend to continue selling through our resellers, but we are also looking for synergies with some larger corporations who could take advantage of speeding up the process of our rolling out this technology, both the beamformer and also the antenna. Some of the large corporations may require their own electronically steered antenna that we have spent about 7 years developing, and they may not want to develop this technology themselves. So there is always a potential that somebody would be interested in buying the company or acquiring the technology or licensing the technology. So there's many things that will come out of the woodwork over the next year when we start manufacturing and selling these products. So that is basically what we anticipate that it will happen over the next 12 months or so. Sam Strisco, what are the main drivers of revenue growth for CCOM in the next 2 to 3 years? And do you anticipate any seasonal or cyclical trends in your whatever? Yes, unfortunately, Sam, the business is very, very cyclical. It is up and down, and you can see from year to year, we had years where we sold $20 million worth of product, and then we had years where we sold only $8 million worth of product. But being small, being outsourced, and not having any other offices anywhere in the world makes it possible for us to operate on a very low overhead basis. And so the cyclicality will not go away. But if we have some synergies with some large companies who may want to manufacture and distribute the products that we have developed, that may change the cyclicality of the business. But the business is definitely cyclical and has been cyclical over the last 28 years. There's Ed Parella, what differentiates CCOM's antenna technology from other providers in the mobile SATCOM and mobile SATCOM? So our antennas are differentiated in a way that they're the same modules that we build for GEO, LEO, MEO can be used for all type of satellite, existing satellites, for example, GEOs that are up there, and also newer type of LEO satellites. So we can build very rapidly from the panels that we have developed an antenna that will work on LEO, or can be beefed up by including multiple panels to MEO and GEO. So we believe that our antennas are more advanced than many others, and with the phased array, with the beamformer chipsets that we are developing, we believe that we'll have an edge, because most of the antenna manufacturers are buying those chips from off the shelves, and those off-the-shelf chips are very expensive. So they make the antenna prohibitively expensive in many ways. And we hope to reduce that cost dramatically. So we hope that our technology will be used in many of the new MEO, LEO type of satellite applications. And the fact is that they can also be used for existing GEO applications, of which there are thousands of satellites up there with a lifespan of 15 years. And these antennas are going to be able to extend the satellite, the lifetime of those satellites by delivering mobility to those satellite service providers. Okay, there is George who is asking, Ed, let's see, capital, it's hard to see this stuff. 60 million, zero debt as of August. How does the company plan to deploy its capital to drive growth? So the company is planning to deploy the capital by spending more on R&D and making sure that the product can be launched and manufactured and continue to be developed. So we stopped paying dividends for the reason that we wanted to make sure that we preserve the cash for research and development, and until that is finished, that's the way the cash is going to be deployed. We have, as I mentioned before, paid out $25 million in dividends. So the cash could also be used to buy back shares at some point if the board agrees with that, or used to pay special dividends or whatever. We have no intention at this stage to acquire anybody with the cash, because we are focused on developing these two new technologies that we have spent many years developing and want to launch it and get it into the marketplace. So the cash is a good cushion to have. It's always good. It's better to have cash than not to have it. And since we are not interested in going to raise funds, it's always nice to know that there are enough funds there to continue the R&D that we are doing, and making sure that we have enough cash to finish the project and get new projects also going with them. Okay, let me just see. George, I think I answered that. Any other questions? I don't see any more questions from the audience. I guess if there are no more questions, I would like to thank everyone who participated, and also OTCQB for making it possible for me to present this to every one of you. Thank you very much.